Alright class, in this session we are going to continue the vectors and it's question number 11 from your new book. The question says, with respect to an origin, the position vector of A is 3, 4. So we have OA that is equals to 3 and 4 in terms of column vector, and we have position vector of B which is equals to 5 and 5. The points A, B and C are such that BC is equals to 2 times of AB. Find the position vector of C. In order to use that condition, firstly we need to find out the vector AB. Right now I hope that all of you can easily find out the vector AB. So firstly you need to find out the vector AB and you have a time of 60 seconds, so start. Alright. AB is what? AB is OB minus OA. If you remember the working formula, then it is quite easy to find out the vector AB. So OB is what? OB is 5 and 5 minus OA is 3 and 4. So 5 minus 3 leads to 2 and 5 minus 4 leads to 1. That is a vector AB. Now once you have find the vector AB, you can find the vector BC now. It will be equals to BC is equals to 2 times of AB, and AB is what? It's 2 and 1. So the vector BC, that will be 2 2s are 4 and 2 1s are 2. That is your vector BC. Alright, and after that with the help of BC we can find the position vector of C, and the equation will be OB plus BC is equals to OC, or we can say that directly BC is equals to OC minus OB. Alright, since we are looking for OC here, so I'm going to use this equation. So OB, it's given that is 5 and 5. BC we had find out it's 4 and 2 leads to OC, which we are looking for. So 5 plus 4 9, 5 plus 2 7. So 9 and 7 are the vector coordinates for OC. Moving towards the next question, it's question number 13. The question says, with respect to an origin, the position vector of A, B and C are minus 2i plus 7j, that is your A. B is 2i minus j and C is 6i plus lambda j. Find the value of lambda when AC is equals to 70. Alright, so you need to find out the value for AC here. Alright, the condition we have is the magnitude of AC is known, right? So magnitude of AC is equals to 70. First we need to find out the vector of AC, that will be OC minus OA, right? The OC vector is 6i plus lambda j minus the vector OA is minus 2i plus 7j is equals to 17. Alright, but we are not going to write 17 here because it is not the magnitude. So firstly it will be 6i plus 2i plus lambda minus 7j. Alright, 6 plus 2 it's 8i plus lambda minus 7j. That is my vector AC. To find out the magnitude, we know the working formula for magnitude is 8 square plus lambda minus 7 square with the under root sign, right? The magnitude of AC, it's 17 is equals to 8 square 64 plus lambda minus 7 whole square with the root sign. Applying squaring on both sides to eliminate the under root sign here. Alright, so 17 square is 289. So now my equation will be 289 minus 64 is equals to lambda minus 7 whole square. 289 minus 64, it's 225 is equals to lambda minus 7 whole square. Apply root on both sides. So 225 is plus minus 15 is equals to lambda minus 7. So when you are going to pick plus 15, so that will be 15 plus 7 is equals to lambda, and minus 15 plus 7 is equals to lambda. So lambda is equals to 22 and lambda is equals to minus 8. these two are the possible values for lambda for your first part. Alright, so first we need to take first we need to complete the other part B. Find the value of lambda when ABC it's a straight line, right? So when ABC it's a straight line, I'm just roughly sketching it. That means now we need to apply the concept of a scalar multiple. Alright, that means they are a scalar multiple to one another, and we need to find out the value of lambda here. Alright, so AB is equals to K times BC, or you can arrange the equation in the form AC is equals to K times AB. It does not matter if the points are on the straight line, so they are a scalar multiple. Alright, so you can pick any two with other two variables. There is no hard and fast rule. Alright, after that we have the vector AB, and it's what? AB we can find out, it will be OB minus OA is equals to K times OC minus OB. Alright class, now we have OB and OA. OB is what? It's 2I minus J minus plus 2I minus plus minus 7J. I have directly multiply with a negative sign. K times OC is what? OC is 6I plus lambda J minus OB is what? Minus 2I plus J. Alright, after that we need to solve. 2I plus 2I, it's 4I minus 7 minus 1 minus 8J equals to K times 6I minus 2I, it's 4I plus lambda J, it will be lambda plus 1 and J. I have taken J common here. Alright, now the benefit of it, we are going to equate I with the I. So on my left side the coefficient of I is 4, on my right side the coefficient of I is 4K. So you got the value of K and it is equals to 1, right? Similarly, if we are going to compare J coefficient, so that will be minus 8 on the left side, and on the right side it's K times lambda plus 1, right? Now we have the value of K, that is 1, so minus 8 is equals to lambda plus 1 and lambda is equals to minus 9. Alright, so that is your final answer. Now before proceeding to the third part, you need to write down the solution, these two solutions in your copy, and to write down these two solutions you have a time of 5 minutes. You note it down and then I will start the next part, C. So start. Alright class, in the last part, part C, it says find the value of lambda when ABC is the right angle triangle. ABC is right angle triangle, right? For right angle triangle we know that angle is equals to 90 degree, and 90 leads that the lines are perpendicular. Alright, for condition for perpendicular line, we know that the gradient is negative reciprocal, right? M1 into M2 equals to minus 1. But how we are going to apply this condition? So we have the vector AB, and the vector AB we have, it's 4I minus 8J. The gradient of AB is minus 8 divided by 4 leads to minus 2. Similarly, the vector BC we have, it's 4I plus lambda plus 1J, and the gradient of BC is lambda plus 1 divided by 4. It's simply y2 minus y1 divided by x2 minus x1, or you can say that change in y over change in x. The condition for gradient, we know that it's m1 times m2 equals to negative 1. The value for m1 we have, it's minus 2. The value for m2 we have, it's lambda plus 1 divided by 4 is equals to minus 1. Minus cancel, 2 1s are 2, 2 2s are 4. So now we have the leftover is the lambda plus 1 divided by 2 equals to 1. Lambda plus 1 equals to 2, and the value of lambda 2 minus 1 leads to 1. That is your answer. You need to write down the solution in your copy, and for that part you have a time of 60 seconds. So start. Alright, after that, moving on to the next question. It's question number 14 from your book. With respect to an origin, the position vector of A is minus xi plus 4j, and the vector B is 18i plus 6j. C lies on the y-axis, and OC is equal to OA plus lambda OB. Find OC. Alright, so you need to use this equation here. It says that OC is equals to OA plus lambda OB. Alright, the value for OA we have, it's minus 6i plus 4j plus lambda OB is 18i plus 6j. Alright, and that is equals to OC. We need to find OC, but the important condition is C lies on the y-axis. That means the x coordinate will be 0 here. So for OC, I can say that it's 0i, that is very important, plus j, and the value of j, let's suppose it's any variable. Let's suppose I'm pick p, bj, right? OI plus bj is equals to, now here it's minus 6i plus that will be I, 18i, right? Then minus 6i plus 18 lambda I plus 4j plus 6 lambda j. So I multiplied the bracket with lambda and gather all the I and j terms together. So the I term I have, it's minus 6i plus 18 lambda I, and on my left side the I term is 0i, right? What I am doing, I am just comparing the coefficients of I here. So now it will be 6i is equals to 18 lambda, 6 is equals to 18 lambda, and you got the value for lambda, that is equals to 1 upon 3. Similarly, if you compare your j, so b is equals to 4 plus 6 lambda. B is what? B is equals to 4 plus 6, lambda is 1/3, 3 2s are 6, 4 plus 2, 6. So the vector C we have, OC, it will be equals to 6j, because the x coordinate will be 0, it cuts the y-axis, so it is only left over with 6 coordinates, 6j. You need to write down the solution in your copy, and you have a time of 90 seconds, so start. Alright, after that, moving on towards the next question. It's question number 15. With respect to origin, the position vector of P and the position vector of Q are known. R lies on the x-axis and OR is equals to OP plus mu OQ. So that is very much similar question we have attempted previously. So first you need to give it a try by yourself, and for this question the time is 4 minutes. Give it a try, so stop. Alright, the equation we have, it's OR is equals to OP plus mu times OQ, right? The value for P and Q are known, so I'm going to say that OP is what? OP, it's 8i plus 3j plus mu. OQ is what? OQ is minus 12i minus 7j. I'm going to gather the I and j terms all together, so it will be 8 minus 12 mu I. Alright, I have multiplied the bracket and gather the I terms, plus 3 minus 7 mu and j. Since R lies on the x-axis, that means the y coordinate is 0. So I can say that for I it will be AI plus 0j. Alright, and I need to equate j terms with j term, right? So now on my left hand it's 0 equals to 3 minus 7 mu, and I will get the value for mu, it is 3 divided by 7. Once I got the value for mu, it is quite easy to find out the value for A here. How? I'm going to compare the coefficient for I. So it will be A is equals to 8 minus 12 mu, that is given, and I can highlight it with a green pen so you can easily relate it. It will be A is equals to 8 minus 12, mu is what? Mu is 3 divided by 7, right? So now it's 8 minus 12, 3s are 36 divided by 7. Taking LCM, 7 8s are 56, minus 36 leads to 20 divided by 7. Alright, so the answer, how you are going to write down the answer? The answer for OR is equals to 20 divided by 7i, because the R lies on the x-axis, that means the y coordinate is 0, so that is your final answer. I hope that you got the concept and how to solve this type of question. So I think that it is quite enough for today class. Inshallah in next class we are going to continue with that same topic.